Welcome children. Today we will take chapter 2 Polynomials Application of Identities. Here is the sum and let us factorize the sum using appropriate identity. Now you can see the algebraic expression 9x squared plus 6xy plus y squared. Now, we can write this in the form x squared plus 2xy plus y squared. Let us see how to write. What is the square root of 9? It is 3 and the square root of x squared is x. Write it in the bracket. You get 3x whole squared. As well as what is the square root of y squared? It is y. Write that y in the bracket and square it. Now this is the first term and this is the last term. And what is the middle term? 2 into first term into last term. So 2 into 3x into y. We can observe that we can apply the identity x plus y squared is equal to x squared plus 2xy plus y squared. See, can you identify this identity with this particular sum? Yes, you can see that x is equal to 3x over here and y is equal to y over here. And the middle term 2xy is equal to the same 2 into first term into last term. Now we have to factorize. So what is the factor form of this identity? It is x plus y whole square. Now let me remind you that the factor forms are always in the bracket. So whatever is in the bracket is the factor form and this is the expanded form. So if the question is related to expanded form, your answer will be in this form. If the question is factorized, then your answer will be in this form. Here we are factorizing, so our answer will be x plus y whole squared form. And for this sum, we will replace x with 3x and y with y. Hence it is 3x plus y squared. So here children we are with identity 5. In this identity we are having 3 variables and we are going to square the sum of these 3 variables. So let us take the sum of the variables and square it. Then let us find the identity. The identity is x squared plus y squared plus z squared. Then turn by turn you will have to take the product of the 2 variables along with 2. That is 2xy, then plus, now the product of next 2 variables y and z with 2, so 2yz, and in the last term it will be the product of last variable and the first variable, that is zx, that 2 with 2. So first 3 are simply squares and the last 3 are having 2 as the numerical coefficient and the product of 2 variables consequently 1 by 1. So remember the identity, we are going to apply it in our sums. Here we are going to expand the square of this algebraic expression using suitable identity. Now let us find out which identity is suitable over here. You can see that these are 3 variables and we just learned the identity which is suitable for the square of 3 variables. Here is the identity. It is x squared plus y squared plus z squared plus 2xy plus 2yz plus 2zx. Now we are going to replace x with x, which is in our question. Y is equal to 2y, which is given over here, and z is equal to 4z, which is again given as the last term in our question. So replace the x, y, z of the identities with those given in the question. That's all you have to do. But be very careful while replacing. Don't forget to put the brackets. Like x means x whole squared. Y over here is replaced with 2y whole squared. This is very crucial. Write the bracket and we say it is whole square. It's not 2y square, it is 2y whole square. And then replace z with 4z. So you get 4z whole square. And then ultimately these terms are the product of the two variables with 2. So first two variables are x into 2y, which we are given in the question. So first two variables x into 2y multiplied by 2. The next two variables 2y into 4z multiplied by 2, and the final two variables are 4z, which is the last term, and x, which is the first term. So 4z into x. And then the final step is just to do the calculation. Now you can remove the bracket and you can write x whole squared as x squared. But here you see, if you didn't put whole squared, you would have written 2y squared. But actually the answer is 2 squared means 4y squared. Similarly over here, 4 squared means 16 z squared. And here you have to multiply the numerical coefficients first. So 2 into 2, 4, then xy plus 2 into 2, 4 into 4, 16yz, and finally 2 into 4 is 8zx. We are going to factorize this expression using appropriate identity. So first you must find out which identity is suitable for this expression. Now here you can see it is of the form x squared minus y squared. So which identity will be suitable for this expression? It will be x squared minus y squared is equal to x plus y, x minus y. Now understand that this is the factor form and this one is the expanded form. Here it is asked to convert this expanded form into factor form. Now how can you understand what type of expression is called factor form? What type of expression is called expanded form? So let me give you a trick to understand it. Whenever there is a factor form, you will have brackets. Always you know the factors are products. So this is of the form of product. Like what are the factors of 15? 5 multiplied by 3. So this multiplied means bracket. So factor form is of this type. But expanded form is always having the operation of addition or subtraction only, not multiplication or division. It will have the operation of addition or subtraction in between the terms. So that is the expanded form, and that is the trick to understand the difference between expanded form and factor form. At present, we are converting this expanded form into factor form. So we understood the factor form will be x plus y, x minus y. Now, only thing that you have to do is you have to find the square root of the numbers or the variables in the expression. Here what is given? X squared. So write the square root of x squared and find it out. It is x. Similarly, find the square root of y squared upon 100. It is y upon 10. So what will we get? X plus y upon 10 and x minus y upon 10. Here we are replacing y with y upon 10 and x is as it is. So just you have to replace y with y upon 10 in both these factors and your answer is ready. We are going to factorize this algebraic expression. And which identity are we going to use? We are going to use the identity x plus y plus z squared is equal to x squared plus y squared plus z squared plus 2xy plus 2yz plus 2zx. How can we come to know that we are going to use this identity? Because it is the sum of three variables and square of the sum of three variables. Here you can see the three variables over here they are. So from these three variables and its square, we can understand that this identity will be the suitable identity. You have to write the identity. Don't write that by identity 3, by identity 4. That way you don't have to write. You have to mention the identity over here. The next step is that you find the square root of the three terms in the beginning, which are given in the beginning. That is the trick. Find the square root of the three terms in the that are available in the beginning of the question. That is square root of the three variables. The first variable is x squared, but its coefficient is 4. So we are going to find the square root of 4x squared, that is 2x, square root of 9y squared, that is 3y, and square root of 16z squared, that is 4z. That's all. Half of your sum is over. Now just you have to replace these values in the identity. In the place of x, we will replace 2x, but we will take whole square. In the place of y, we will replace 3y and we will take whole squared. Similarly, in the place of z, we will replace minus 4z and we will take whole squared. And then we are going to multiply the product of two terms at a time along with the number 2. So one by one, we are multiplying the product of first two terms, then the product of second two terms, that is 3y and minus 4z. And finally, we are going to multiply the last term and the first term. And then we are going to compare it with our question. You will find that this the values obtained by uh, simplifying this expression are equal to the values in the question. Hence, what is the factor form of this expression? It is 2x plus 3y minus 4z. From where did we get minus 4z? Because you can see that the last two terms are in minus. So again, one trick you have to apply. Either y will be minus or z will be minus. Because here you can again see that x and y are not minus. If any one of these two will be minus, then here you would get minus, but here it is plus. It means when here it is a positive sign, x is positive, y is positive. Then what will be negative? Only z is remain which can be negative. Hence here we got the z in negative coefficient of z, that is minus 4. So you have to apply tricks everywhere. You can see that x and y both are positive. If any one of them was negative, then here the sign would be negative. So both of them are not negative, then one alone is remain which can be negative, and that is z. Another important thing is that the z is found in both these terms. Hence both these terms are negative. So you can understand that z is the negative, z is having the negative coefficient. Here is an assignment for you. Do it properly, practice properly. All the best. Thank you.